Hey math enthusiast, I'm here to continue the notes on the trig functions sine, cosine, and tangent. So let's pick up where we left off. So for this problem, I'm asked to figure out the area of this triangle, and I'm going to round my answer to the nearest tenth once I'm done. So let's just recall what my formula is for the area of a triangle. So it's 1/2 base times height. So in order to calculate this formula, I'm going to need both the base and the height. Well, it looks like I do have the height here, which is 24, but I'm going to need to figure out what this base is, what this x value is. So let's take a closer look at our triangle. So the first thing I notice is it is a right triangle. And they give me this other angle, this 61 degrees. So I know right away that the side that is left blank is the hypotenuse. That 24 feet, I could call that the side opposite the 61 degrees, which means the last side, x, the side that I'm looking for, is the adjacent. So since it's a right triangle, I have one side, I'm looking for another side, I'm going to use the trig functions. So let's jot down our list again. So, ka, toa. And let's figure out what function we're using. So obviously I'm going to be using the opposite side because that's what they give me, and I'm looking for the adjacent side. So it looks like in this case the function that uses opposite and adjacent is the tangent function. So we'll continue with the tangent function. Following that is my degree. So I'm looking for the tangent of 61 degrees. And I know that's going to equal the ratio of the opposite side, which is 24, over the adjacent side, which is x. Now, if you recall the shortcut that I showed you back in part 2, there's an easy way to solve these problems when your variable is in the denominator. If you're not aware of the shortcut, then I'm going to walk through the steps real quick again. So what I'm going to do is multiply both sides by x, or x over 1, to get rid of my variable in the denominator. So in this case, what I'm going to be left with is x times tangent of 61 degrees equals 24. Next thing I want to do is get x all by itself, so I'm going to divide by tangent of 61. Have to do that on both sides. And what's going to happen on the left-hand side is that these two are going to cancel out. So I end up with x all by itself, which is going to be equal to 24 divided by tangent of 61. So what we can do is first change that tan of 61 degrees into a decimal. So this way I can divide. So that's going to change to 1.0840. So I'll just leave it as 1.804. And then when I plug that into my calculator, we end up with 13.3. So now I can fill that into my triangle up above. So now I know my base is going to be 13.3. So now I can use this to calculate my area. So let's clean up what we have here. So for my formula for the area of a triangle, it's equal to 1/2 the base, which I now have, 13.3, and the height, which is 24. Now, since this is multiplication, I'm essentially just multiplying all of these values together. If it helps, you can always rewrite a half as a decimal and change it to 0.5 times 13.3 times 24. So after I multiply those three together, it looks like the area of my triangle is 159.6. And the units they were using were feet. So it's going to be feet squared. Now for the next problem, number 4, they want us to find the perimeter of this triangle below. First thing I notice is we're dealing with a right triangle, and they do give me one other angle besides that, the 55 degrees. So it looks like in this case I'm going to end up using my trig functions, so I'll write out my list real quick to help me find the other missing side lengths. So let me label my 3 sides. Hypotenuse is the easiest to pick out. It's across from the right angle. The one side they do give me, that 47, is opposite because it's across from the 55 degrees. And the last side on the left is the adjacent. The other thing I'm going to do, since I'm looking for the perimeter, I'm going to need those 2 missing side lengths. So I'm going to throw some variables in there. We'll call the hypotenuse x, and I'll call the adjacent side y. Okay, so now I need to figure out what function I'm going to use to solve for either of these variables. Well, let's start with the hypotenuse. So I'm going to be using or looking for the hypotenuse, and I'm going to be using the opposite side. So let's go to our list of functions and see what function uses the opposite and the hypotenuse. So that would be the sine function, so we'll start with that. So it's going to be the sine of my angle, which is 55 degrees, and the sine function is equal to the ratio of the opposite side, which is 47, over the hypotenuse, which is x. Now this problem is like the previous one, in which case I have my variable in the denominator. So instead of going through all those steps algebraically, I'm going to use the shortcut that I talked about in part 2 of the notes. Anytime that variable is in the denominator, essentially what's going to happen when you go through all those steps algebraically is these two are going to switch places. So I'm going to end up with x on the left-hand side, and on the right I'm going to have 47 divided by sine of 55 degrees. Now, to help me calculate this, first thing I'm going to do is change that sine of 55 degrees to a decimal. So I'm going to end up with 0.8192. And then when I plug that into my calculator, I'm going to end up with 57.4. Okay, so now I have a value for x. So I'm going to go back to my original picture, and I'm going to fill that in. So I know the top side of my triangle is 57.4. Now I just need that last side, that adjacent side. Okay, so even though I do have the hypotenuse, I'm still going to stick with using the opposite. So now I want to figure out what function uses both opposite and adjacent to help me solve for y. Well, it looks like opposite and adjacent is going to be the tangent function. So once again, let's start off by jotting that down. Tangent of my angle, I'm using the 55 degrees, is equal to the ratio of the opposite, which was 47, over the adjacent, which is y. Now, once again, my variable is in the denominator, so I'm going to use that shortcut that I discussed earlier, and I'm going to take these two pieces, that tan 55 and my variable, and they're going to switch places. So I know y is going to be equal to 47 over tangent of 55 degrees. So once again, let's change that tangent of 55 into a decimal. So I end up with 1.4281, which gives me 32.9 for that third side. So I'll go back to my original picture and we'll fill that in as well. So let's just recall what exactly they were asking for. They wanted to figure out what the perimeter was to the nearest tenth. So I've rounded each of my decimals to the nearest tenth. So now I can add up my three values to figure out my perimeter. So the 57.4 plus the 47 plus the 32.9. Which gives me 137.3. And my units in this case were inches.